Yeah, hi everyone. So this video I will discuss about calculation. So yesterday we learned about on how to draw the ray diagram. So now we focus on calculation. So here we have one particular formula, spherical mirror equation, where 1 over f is equals to 1 over u plus 1 over v. Okay, so like I told you before, this is basically a vector equation, means that each one of these has a sign convention of positive and negative. So if you guys still remember, yesterday we still have f equals to r over 2, and if I substitute this one inside here, then you get basically this equation, same equation, just that in terms of r. Okay, so as a recap, f is the focal length, so f is focal length. It can be positive or negative. So if it is positive f, it means that the behavior of the mirror is converging. Okay, if it is negative f, it means that diverging. In terms of mirror's name, so converging mirror is basically your concave, okay, that has a shape like this. On the other hand, for convex, it's diverge, and the shape looks like this. Okay, so if you guys forget, you can always remember perumpamaan kuali yang saya buat tu lah. And then u is the position of the object, so normally it's positive. V, position of the image. Okay, this one can be positive or can be negative. So positive V means that the image form is real. Negative V means image form is virtual. What does it mean in terms of maybe your drawing? So in this case, if your object is on the left hand side, the image might be formed in the same side, like that. Example. Okay, I mean this one, the size and everything you have to check back lah. If this one, it means that the image is formed on the opposite side. Example maybe something like this. Okay, so if you want to understand the concept, the mirror are supposed to reflect the light, right? So all the light should be reflected on this side, so the image should be formed on this side. Okay, same side as the object lah. So if that's happened, that means the image is real. Okay, on the other hand, if it is formed on the other side where it's not supposed to be, then this one is a virtual image. Okay, like in this example lah. Okay, the next equation is basically magnification. So remember, you just have a few equations. Yesterday it's about this one, today we learn this one, and another one is this one, where m equals to hi over h naught and negative v over u. Hi means m is the magnification itself, hi is image height, h naught is object height, okay, and then your v is the position of the image and u is position of the object, same lah. Okay, this one is still a vector formula, means that each one of these can be positive or negative. This one applies same with previously. Okay, so if you have negative v, you have to substitute negative v inside here. Okay, And remember that this one you have a negative there, but this one you don't have negative. Okay, this equation don't have negative. And then if height of the image is negative, that means that the image is inverted. Maybe I can bring this one down. Oops. Okay, so if H image is negative, it means that inverted. So the image form is inverted. If the height of the image is positive, it is upright. Okay, and then you have M, the values of M. If it is more than 1, it means that it is magnified. If equals to 1 means that it's same size. If less than 1, it means that diminish. Okay, and then positive M means this one is upright, similar to the height of the image, right? So if this one is positive, upright. If negative, inverted. Okay, so one thing common mistake that students make is when they want to determine whether it's diminished or not. Okay, so when they see that this one is less than 1, so they assume any negative number is less than 1, but that's not true. Okay, because we are talking about the magnitude only. So example I show you over here, if you have m equals to negative half. Okay, so the negative here, negative and the number is that you have to treat it separately. Like this negative, it means that it is inverted. Right, this is a negative m value, so negative means it is inverted, like this one. Okay, and the half there, you have to treat separately. This number, the magnitude of m, numbers only, represent diminished. Why this one is diminished? Because half is less than 1. Okay, so the number should be between 0 and 1 lah. So anything between 0 and 1, you consider that one as diminished. Okay, another example, m equals to 4. So m is equals to 4 is basically m equals to positive 4. Again, the positive here means it is upright, while the 4 here represent magnified. Okay, and then I'll give you another example. Let's say if you have m is equals to negative m be negative 2. Okay, so again you treat this one separately. Okay, just erase this one. It's 4. I just change the bracket to separate. Okay, so like this one, the negative here means it is inverted. The positive, the numbers 2 here represent that this one is magnified because it is more than 1. So you can see that even though this one is negative 2, okay, but since it is negative, it means that the image is inverted. Magnified means the image is magnified. Sorry, 2 means the image is magnified. Okay, let's try to look at one example here. Okay, it says that a concave mirror has a focal length of 20 cm. Object is placed 10 cm in front of the mirror. How far from the mirror the image will be formed? Okay, so it is a concave mirror. So my suggestion, if you try to solve this kind of problem, first thing first, you try to sketch, okay, the position of the mirror and the position of the image. Predict. Okay, so this one is a concave mirror, so this is just a rough drawing. So because this one is a concave, you can see that the F would be positive. Why? Because this one adalah converging. Okay, you can imagine that if the light goes in, everything will be converged. So it's positive f. So given that the values for focal length is 20 centimeter, so it becomes positive 20 centimeter. Okay, that one is your f. So f on this side and c will be on that side. Okay, remember mirror, you only have f and c on one side only. So you can expect if the object is 10 centimeter, so the position would be less than the focal length. Okay, maybe somewhere over there. As a result, okay, if you do it multiple times on the ray diagrams for drawing, so maybe you can predict. Okay, so the image would form maybe somewhere over here. Okay, if you're not sure, you can always try to check by drawing the ray diagram itself. So to solve this one, okay, after we solve, and then maybe we can see whether this one does this one agree with our calculation. So 1 over f is equals to 1 over u plus 1 over v. F is 20, u is 10. So if you solve v, 1 over 20 minus 1 over 10, you should get negative 20 centimeter. Okay, so the negative sign here represent that the image is virtual. Okay, if it is virtual, then you can write down the position, because they ask you the position, right? So you have to write same side with object. Okay, and then maybe I can add my notes over here. Okay, here. So if it is real, the image is same side. If it is virtual, opposite side. Okay, so this one is opposite. Can mix it up. So this one is opposite side to the object. Okay, just to be sure. Okay, so this one, the image is virtual, opposite side. So our prediction agrees with this final answer. Maybe if you want to really make sure, okay, maybe you can try to calculate the m, even though the question doesn't ask. V equals to negative v over u. So this one is equals to negative, remains, okay, negative v is negative 20, u is equals to 10. So m will be equals to positive 2. So this one, these numbers here indicate that this is upright image and magnified. Okay, so you can see that this one, all the properties here agrees with the initial prediction. So in a way, maybe you can say that all your calculation is correct. Okay, so next question is question number 8. It says that an object is placed 3 cm in front of convex mirror of focal length 6 cm. Calculate the position and the magnification of the final image. So this one is question 8 from the tutorial. Okay, so it says 3 cm. The mirror, the type of mirror is convex. Focal length is 6 cm. Calculate the position and magnification of the final image. Again, before you start, try to sketch so that you can get some ideas on where the position of the image would be. So it's a convex mirror. This is your object, right? So u is equals to 3 cm. focal length is equals to 6 centimeter. Remember, this is a convex, and you can see that the mirror actually diverging mirror, so negative f. So you can see even though the question doesn't say that it is a negative 6, you have to put the negative it yourself. The position of the image would be formed somewhere over there. I mean this one, because convex mirror always form image over there. So this is your image, okay, and this is your f. Calculate the position and magnification of the final image. So to calculate the position, basically the question we want to find V, you can use this formula. F is equals to negative 6. And if you solve V, then you should get negative 2 centimeter. Okay, and straight away you know that the image should be virtual. So to calculate M, the next question they want to calculate magnification. M is equals to negative V over U. So negative 2 over U is equals to 3. So like that lah. So you can leave it in 2 over 3, but here because I want to show the characteristic of the image clearly, so I put it in decimal, so it becomes positive 0.67. Okay, magnification doesn't have any unit, remember. Okay, I just double check that one. Okay, here the positive indicates that the image is upright, and 0.67 indicates that the image is actually diminished. So previously when they asked you to calculate V, so maybe you can state the position where this one is opposite side of the object. Opposite side to the object. Okay, so that one's for 7.1. Now 7.2. We want to talk about refraction at spherical surface. So previously we discussed about reflection. Now refraction. The difference is reflection, cahaya terpantul. Refraction, cahaya terbias. The key difference is that reflection, cahaya tak melepasi mirror. Kalau refraction, cahaya go through surface. Okay. So we have one particular equation. There's derivation for this, but I'm not gonna go through that. So this is only one formula. N1 plus N2 equals to N2 minus N1 over R. N1 is basically your refractive index. Maybe I'll write it like this. Refractive index is N, okay, and N1 means at object, or the position of the object. I'm going to explain more later. N2 opposite to object. Okay, R is basically your radius of curvature. So R can be positive R or negative R. Okay, before we go through R, maybe I erase everything here. I want to go through V. Okay, again positive V means real, negative V means virtual. Okay, but the concept is slightly different with the mirror. Okay, because as you can see that this one, refraction, the lights are supposed to pass through. So let's say this is my object. Okay, the lights will come from here, the ray diagram will come from the object, and then it hit a surface. Okay, so supposedly the lights will pass through and the image supposed to be formed over here. So this region is when you have a positive V. Okay, and this region is when you have a negative V. So when it says virtual, this is the virtual part. When it says real, this is the real part. I just write the position, real, opposite. Dia terbalik dengan mirror tadi lah, opposite to object. And this one is same side. So if you understand, then you don't really have to memorize anything, and it becomes so much simpler. Okay, and about N1 and N2 just now. So this is the position of the object. So this would be your N1. Okay, just bring this one down. Okay. So this will be your N1 and this will be your N2. Okay, let's say your N2 over here on this side is a glass, right? So then this N2 is equals to glass. N glass lah. Okay, normally maybe it's around 1.4 to 1.5 something. So I just put here, let's say 1.5. Okay, N by 1, let's say it's air. So if air, they are not going to say the values of N air, but you need to know N air is equals to 1. If water is 1.33. Okay, back to this case, you can see that the ray comes from here. So as it goes towards the surface here, okay, you can see this one like a convex surface. I don't have a diagram. Okay. Okay, from here you can see, okay, this one the lens, sorry, the surface, refraction at the surface. So if you have two types of the surface, like this curve and this curve, okay, so as the light goes in, okay, this one will behave exactly like a lens, okay, and this one will looks like a converging lens or convex lens. Okay, so if you guys remember when you were kids or maybe masa kecil, I used to play with the lens kanta cembung, yang kita biasa buat baca tu kan, and then I used to put on a paper or tissue or something under the lights, under the sun. Then you can see that the lights will be focused at one point. Okay, if you guys remember lah, kalau kamu nak hafal. And eventually paper tu macam terbakar lah. So that means all the lights are pointing in one direction towards the focal point. Okay, because of that your R is positive. Okay, remember, if your object is over here, you will see this type of surface, cembung, from this point of view. Okay, and because of that, the behavior of light is focusing. Because it's focused, then the R is positive. Converging is positive R. Okay. On the other hand, if you have a curve like this, okay, from this point of view, then you see that this one adalah looks like a concave lens. Okay, the lights will be diverging from the focal length. Because of that, R is negative. Okay, so I just put it back over here. So positive R converge, negative R diverge. Okay, so if you see a surface that will give a converging behavior, then it's a positive R. If negative, it's a diverge. Okay, back to this one. So this is your object. Remember, ray diagram will start from the object itself. Dekat mana objek tu berada, kat situ ray diagram mula. So object is over here, ray diagram in this direction. From this point of view, you can see that this one adalah convex. Behavior is converge. Therefore, R will be positive. So this one is positive R. Okay. On the other hand, if I have surface like that. So let's say my object is over here. So this is my object. So a ray diagram or your ray should move from the object. If you look from this direction, from this point of view, so you can see that this one is a concave lens. So it behaves like a concave lens, where this one the lights will diverge. Because of that, R would be negative R. Okay. So all these values you just have to substitute back inside this equation. Okay, we go further. We try to do a few examples. So here question 10 say that object is placed 12 cm in front of the glass rod. If the radius of curvature and reflecting index is 24 and 1.52, calculate the image and image characteristic. Okay, let's try. Okay, first of all, I will try to redraw this one to make the diagram much bigger and clearer. Okay, this is your object, right? Okay, this is the surface here. Okay, so first of all, you have to determine which one is N1 and which one is N2. So N here is air. It doesn't say, but you need to know lah, because N here is glass. So which is equals to 1.52, and because of air, this one is N equals to 1. Okay. So you can imagine if this one is glass rod, the remaining area is air. And then, like I told before, you have to determine which one is N1 and which one is N2. N1 is at the position of the object. N2 is at the opposite position. So this is N2 and this is N1. Okay. So basically you want to apply the formula. You have one particular formula, so you already determine N1 and N2. The formula that you want to use is N1 over U plus N2 over V equals to N2 minus N1 over R. Okay, so U is equals to 12 centimeter, N1 equals to 1, N2 equals to 1.52. Okay, R is equals to 24. Okay, but now you have to determine whether this one is positive R or negative R. So again, you draw a ray from the object itself towards the surface. Okay, so if you view the surface from here, then you can see that this one is like a convex lens. Lights will be focused or converge. Therefore, R is positive. So I substitute back inside the equation. N1 is 1 over 12 plus 1.52 over V equals to 1.52 minus 1 over 24. Okay. Normally I would solve the right hand side first. So my V here is equals to negative 24.64. Okay. So again, the negative here means the same thing, that the image form is virtual. Okay. But remember, this one is slightly different than the mirror itself, because virtual here means, okay, you can see here. Okay, this is the object. Light supposed to pass through. The image should be formed somewhere over here. So this part is real. Okay. This one will be virtual. Okay. So negative means virtual, and it means that same side with the object. Okay, I just take this. Oops. Just want to color this one. Oops, it's too big. Okay. And then the next question, they want to state the image characteristic. So obviously, if you want to draw the ray diagram to determine, you can, and you can assume that this one is similar to the convex lens, and you can draw exactly ray diagram that looks like a convex lens. Okay, alternatively, which is much easier and much accurate, we suggest you to do the calculation of m, which is negative v over u. So negative 24.64 divided by u, which is equals to 12. So my m here will be equals to 2.05. It's positive, but negative and negative there. Okay, and because this one is a positive number, so positive here means upright, and 2.05 means this one is magnified. Okay, so the question wanted to state 2, so image characteristic. So maybe I just list all 3. Upright, but in exam if they ask you 2, you just have to state 2. If you write 3 and then you got wrong, then minus 1 mark lah. Upright, magnified, and please don't write upright and virtual and ask the pemeriksa to choose it for you. That one will be wrong. Upright, magnified, and virtual. So if you go back to our drawing here, then that means our image form maybe somewhere over here, so the same side is upright and it magnified, and if you look at the values for v, it's bigger than the u, so maybe the image form would be somewhere over here. Okay, all right. And then the last question that we discussed is question 11. A dried flower is inside a glass sphere, so you have to draw. So this is my sphere. Okay, radius is 30 centimeter. So r is equals to 30 centimeter, but we have to determine whether it's positive or negative later. The refractive index of the glass sphere is 1.5, so n here is equals to 1.5. Again, you have to determine which one is n1 and which one is n2. So outside the glass sphere is air, so it equals to 1. U is equals to 20 centimeter. What else? Okay, I think that's all they give, right? So 30 centimeter, 1.5, 20 centimeter. Determine the position of the image. Okay, and remember that the flower is inside the glass sphere. So the object will be over here. Okay, this is the radius, which is length 30 centimeter. So 20 centimeter maybe somewhere over there. Okay, so this is the position of the object. Because the object is inside the sphere, your n1 is basically n1 of the glass at the position of the object, n2 on the opposite side. Okay, and basically you want to apply the same formula where I just write the formula over here. N1 over U plus N2 over V equals to N2 minus N1 over R. Okay, so you already determined N1, N2, and then U you already given. You are given U. Now you want to determine whether R is positive or negative. Okay, draw the ray diagram. So you draw the ray from the object towards the surface. So basically your point of view is from here, and you can see that the surface here that looks like a concave lens, the lights will be diverging. Okay, so because light will be diverging, that means this one R is negative. So you have to put the negative manually. Okay, so here N1 to substitute back inside the equation. N1 equals to 1.5. U is equal to, U is positive, the negative is R. So u equals to 20 plus 1 over v. Okay, be careful with the right hand side here. N2 is equals to, okay, maybe I can write it down again here. N1 equals to 1.5 and 2 is equals to 1. So 1 minus 1.5. Because we get used to bigger number minus smaller number, so sometimes student mix it up. Okay, that's why you have to be careful. Okay, it does not depends on which one is bigger, it depends on the position of the object. So it should be N2 minus N1. Okay, and N2 is 1.5. R is equals to negative 30. So don't forget to put the negative there. So if you solve the right hand side, you should get V equals to negative 17.14. Okay, and because this one is negative, that means that the image form will be virtual. Okay, and in this case, visual means same side. So basically, light passes from here, light should be passes through here, image should be formed here. This is the real part. If virtual means that the image form over there. So I just write down same side as object.
Cubalah ambil gambar paling dekat yang sedekat yang mungkin lah kan.
Okay, and then if you look closely, the V here is 17. Okay, and the U there just now is 20, right? So maybe the image form is somewhere over there. Okay, all right. Okay, thank you.